Hi, I'm Jacob. I'm a forward-deployed engineer here at Palantir. Today, I'm excited to show you a project I've been working on recently that uses the free AIP Dev Tier. This is a React application that leverages the Ontology SDK along with the new Platform SDK. Before I dive into these tools, I'll give you some background on my project along with the demo of the actual application. This is Foundry for Tunes, an online music platform built with React where users can upload and stream their own music files. Unlike the subscription-based services, this kind of platform is perfect for people with large collections of unique audio files not available on the traditional streaming service. Okay, let's jump into the actual application. As you can see, it's kind of empty and it prompts us to upload some music, so let's do that. I'll click this button over here, upload music, brings up this modal, and I will drag in a few files from my Days as an EDM producer. So I'll click open. And as you can see, it starts to upload those songs in parallel. Let me exit out of this. And let's switch to the libraries tab. You can see that they already start to populate as they finish uploading. So this library section is kind of one of the more fundamental sections of the app. We can see your songs, which is just a list of all the songs that you've uploaded. We can see a playlist, and of course there's none yet. I'll get to that in a minute. There's also your artists, albums, and genres. These three are all auto-generated based on the actual songs that you've uploaded. So as you upload songs or you edit the metadata about the songs, your artists, albums, and genres will update automatically. Let's actually try to play a song and see what happens. So I'll go into the artist, I will click play. And as you can see, it starts to play the first song. There's a set of standard controls on the bottom. I can also like the song. I can come over here and see the entire queue. So we can see that it's playing from 7 Days Siege, the artist, and we can see that it has all the songs that the artist has in the queue. I've just clicked play here. You can see that the play count is already updated to 1. And yeah, let me just give it a shot. Now we can see that there's some animation here. You can see that the play timeline is also updating as well. And yeah, those are some of the fundamental parts of the application. Now, there are a few more features I did want to demo. One being the playlist feature that I already mentioned. So to create a playlist and add a song, click the 3 dots, click add a playlist. Because there's none yet, I'll create one. When they click add, and now we can see that here. So click that and it will automatically add that to the playlist. The next feature is on the home screen, we see a few auto-generated sections, including recently played, my recently added songs, and my like songs. We also have search, so I can search for, hook. We can see that, comes up that song on the hook. And finally, I did want to quickly show some of the features over here in the sidebar. One being the dark mode feature, which I really like, and also the keyboard shortcuts. So there's an extensive set of keyboard shortcuts because I really like keyboard shortcuts. You can basically use to control the entire application. Now, let's switch gears and take a look at it. I'll focus on the AIP components and how they integrate into the React application. Be leaving all out though, so if there's anything specific you want to see, like this video and leave a comment below. First, I want to go through the ontology data model. You can see the account. This is created when you first sign up. The artwork of the song, playlists, the songs themselves, the upload action. So this is what is created when you upload a song, whether or not that song actually successfully uploads, and user feedback, which is something I really didn't touch when we went through the demo. There are also a bunch of links that I use in the application, along with a set of action types. And like I said, I don't go through the functions in this video, but I have a bunch of different actions which are backed by functions which actually mutate the state of the ontology. Jumping into the song object type, I wanted to quickly show you my favorite feature in the ontology for this project. Go into the properties tab. I will search for the content property. This is an attachment property. That means it can store any kind of attachment, any kind of file. In my case, this is storing the actual file that the user uploaded. This is really great because it's a first-class feature of the ontology, and it means I don't have to interact with a second service to actually store the file that the user uploaded. It gets stored on the song object itself. Next, I wanted to show the developer console application which I use to generate the Ontology SDK. To do this, I added all the relevant object types. You can see those 6 object types here. and all the relevant action types to the data resources tab. This is what's used to actually generate the Ontology SDK. It's what's used to actually define the scope of the token. For example, when the token gets generated in my OSDK React application, it cannot interact with any object types or action types not listed here. The developer console application also provides a set of API documentation based on your ontology. For example, I can come to the song object and I can see a bunch of ways to actually load the songs into an application. I use this throughout when building my React application, figure out how to load data and also how to apply actions. Now, let's jump into the code. Like I said before, I'm going to focus on the intersection of the OSDK and the React application. Starting in the package.json file, you can see this here is actually your Ontology SDK. How this works is that this dependency actually is pulled from AIP, whereas all the other dependencies would be pulled from, the regular NPM global registry. Before we get into the OSDK code, I did want to quickly show how I use the Platform SDK to fetch the details of the currently logged in user. You can see here, I create a platform client using the access token generated from a sign-in event. After I have this platform client, I can use it to fetch the details here. Now, there's a lot you can do with this Platform SDK other than fetch the details of the currently logged in user. I'm not going to go through everything here. I would recommend going to our public API documentation at palantir.com/docs or check out the GitHub page of the Platform SDK. Jumping into the OSDK code now, I just wanted to show you how I actually initialize the OSDK client. This file is what you get when you initialize the repository using the React application template. The only thing that I changed here is rather than using a default export, I actually I do a named export and use the $sign as the identifier for the client. Next, I wanted to show you how I can use the OSDK to query songs from the ontology and pull them locally into my React application. You can see here, there's this use songs result hook. This is the React hook that I use across the application and across all the code to pull in a full list of songs that a user has in their library. You can also see I'm using this hook called useQuery. This is from the React query library, which is a library I often use when I'm pulling data from a remote server, in this case the ontology, and I want to create a local cache of that data. There are a lot of ways you could do this. You could use Redux, you could use other libraries similar to React Clay. This is just what I prefer to use, and even if you haven't used this before, you should be able to follow along. All the logic for this query is located in this query function right here. Then you can see the usage of the OSDK here. This is the client that we've imported from the edit file that I just showed you. We are passing in the song object type, and because it's an object type that we're passing in, what we get is a set of methods that are available for querying and doing other things against that object type. In my case, I want to only query the user songs, and I want to make sure that we don't only grab the non-deleted songs. This is actually a property of the song object types. I just wanted to make it easy to restore songs later. So in my case, I just used a flag rather than actually deleting the song when a user requests to delete a song. Afterwards, we use this method to asynchronously pull in all the songs. This, of course, is not the most efficient way to do it, because this actually gets called occasionally when the user has the application open. I could optimize this by only pulling in the updates. But in my case, just for this demo, this works just fine. Scrolling down the file a bit, there's a few other hooks that I create, including use recently played songs, use recently added songs, use like songs. These are all ultimately based on this main hook here. And then going down a bit further, what I want to show is how I create action hooks hooks that perform mutations. So for example, use delete song. This is a hook I use that returns a callback that can be used to pass in a song ID and then to delete that song ID. You can see here under the hood, this uses the OSDK again, and it passes in the delete song. And because the OSDK knows that this is an action, instead of getting things for querying an object type, you get the ability to apply the action. This accepts a song. This is fully typed. I just mean like passing the song ID, this will actually error and saying, hey, song ID is not a property of the parameters. Do you move song? And yes, I do. The pattern that I used was I wanted to make the update in the UI immediately while I wait for the action to apply, so I don't have a 2 or 3 second lag from the click to the thing actually taking effect in the UI. The way I did this was using a pattern with React where you can patch the local cache. And I actually have an undo function. If I fail to delete a song in the backend, then I can actually quickly undo that action. So, and then you get the quick feedback, and then you also have the ability to undo that change in the UI if the action did fail. I'll leave it here for this video. There's so much more I could cover, like the functions code, the security model, and the specialized React components I built for this application. If you are interested in a deeper dive, please like this video and leave a comment on the specific topics you'd like me to explore in a future video. If you'd like to try this yourself, you can sign up for your free Dev Tier account at build.palantir.com. You can also find the code for this entire React application at github.com/jsmith/nft. Thanks for watching.